Everyone. This week we talked about a lot of life cycle and that type of stuff. So I'm gonna just go over kind of today and kind of this week and what we did. So the main thing you see now difference is that we are now shooting, instantiating, and destroying these like bullets. I think they're lasers, but yeah. But now we're instantiating, destroying, and starting these lasers after we start the game. And this kind of goes into an object life cycle of our game object life cycle. So let's kind of see what we did in order to start this. The first thing that happened a lot was changing our engine and our engine code mainly. So when we look at our not engine.js, but gameobject.js, there's a couple things that we had to consider. The first thing that we had to consider was start. The start method is called, and we can even go to components of this. But yeah, so the start method is called whenever a game object is instantiated. This will be the first thing that is called or is ran. So when we spawn, for example, when we spawn all of these game objects, before they actually update, there's going to be that start call that is called first. There's a lot of use cases where this is required because what can happen is you need to establish a variable outside of the update call, and not inside of your constructor, because it's not kind of a best practice. You would put it inside of the start. One example would be movement speed. If you have a dictionary of stats and one of those stats is movement speed, and we can't get that movement speed stat in the update because it'll continuously regenerate it. So what we can do is we can just have a this.movement speed equals your dictionary value of speed inside of that start function, which will then allow you to do movement speed wherever. We also had to update our scene a lot because with how we destroy our game objects. So when we destroy a game object, every single time after we update, we have to go through each game object that is marked for destroyed and then call the onDestroy method. Then we call this .game objects, and then we filter out any game object that is true for marked for destroy. What else? So now when we actually look at the code, oh yeah, we also added a clone function. So say I have game object A and game object B, each with their own transforms, and I want to get a reference of game objects A transform to game objects B. For game object B, you will always have to clone the transform, because otherwise it's going to be a direct reference, and that means that it will move whenever the game object A moves. And update the game object A's transform updates will also update game object B transform updates, which we don't normally want. Is there anything else for... Oh, and then another thing that we did was get component. This is going to be this communication between game objects, which we'll show an example in the game. So now how we actually implemented it inside of the bat symbol. Inside of the triangle component, we do a very common practice where we have like a cooldown timer almost, where we have time since last fired equals 1, and time between fire is 1. So we want to fire a laser game object every 1 second. The way we do this is we first add time since last fired plus equals time.delta time, so we can update how much time has passed between this frame and the next frame. If the time since last fired is greater than the time between fires that we want, then we set the time since last fired to 0, and then we instantiate the laser game object at the clone position of our current transform. So so overall, again, this is just a very common like automatic firing cooldown. If you wanted a way to have it be input based, inside of here you would just have to do and input.keysDown.includes, and let's just do space. So now you don't spawn it, but when you do that, you can hold down your space bar, and now you can fire, and if you let go, it stops it, and then I can press it again. So if you wanted it to be input based, then that's kind of a quick and easy adjustment you can do. What else? Yeah, let's look at our laser game object. Inside of our laser game object, we have the triangle and we have the laser component. So let's look at that. Inside of here, we have your update, start, and start, update, and on destroy. But there's a couple things in here that are important to note. Obviously, when we do any movement, we have to multiply by times.delta time. We see if it is less than, the Y transform is less than 50. If it is, then we call the destroy game object, which will then destroy the game object on the next frame because of how our scene works, where when we update, we filter at the end of it. So apologies, it's actually at the end of this frame that we will destroy in. And then when we do, we call the game object.destroy, and then we console.log destroy when onDestroy is called. And then we have the points game. Another important thing is we referenced globals in here. So now we have a globals call where we have a static points equals 0. So now globals.points plus plus, we just iterate that by 1, and then inside of our points component and game object is just a text label and then a points component. And inside of the points component, we get the game object run, we get the component. So this is the communication between components on the same game object. So then we get the component, we get the reference of the text label, which is just whatever the actual not instance of it is, because we don't have the new in parentheses, but the actual class itself. And then we get the text variable from that class, and we set equal to points plus global points. So again, a lot of this is just game object lifecycle stuff. And I'll quickly just go over that again, where you can instantiate game objects, you can update, you can instantiate game objects, you can update game objects, you can draw game objects. But the two main things we added were destroy and start, and those are the core idea inside of the scene, where we always try and start game objects on the first frame possible that they quote unquote spawn in, and then at the end of the frame, if they are marked for destroyed, then they will be filtered out. One final quick thing that is important if you are experiencing a bug is that we're currently calling component.start twice if we add a component. This is because inside of our game objects, when we do this.add component, it will be calling start no matter what. And then when we actually put it into the scene, it will update because the game object hasn't started yet. So it will go into here and it'll say, oh, a game object hasn't started yet. We need to start. The way we fix this is if we just say this.has started. This is a simple fix saying, hey, if you have started already, then you may start this component that you're adding. This is a very niche scenario in this course that I will be exploring in my more advanced turn-based game, because we are going to be adding and destroying components after runtime or during runtime of the game. So there's a lot more kind of use cases and niche cases that need to be accounted for when doing this. Overall, though, if you have any questions, comments, or concerns regarding this week's content, or have bugs or issues, or just send us an email, or send me or Rex an email, and we will solve that as soon as possible. Hope you have a good weekend.